So if you will recall, earlier in the year, we talked about how matter can be classified as either a pure substance or a mixture. Now, for right now, we're going to leave behind this concept of a mixture, and we're specifically going to look at pure substances, which can either be elements or compounds. And in this unit, what we're going to be studying specifically is the formation of these compounds. Now, the reason why we spend an entire unit talking about compounds is because most of the elements that we have on the periodic table, when found in nature, they actually exist as compounds, not as elements by themselves. So, there are two different types of compounds that can be formed that we'll talk about. And while they're very different, what they have in common is the fact that they form these compounds in order to acquire what we call an octet. So form to acquire an octet. Now, before you think, oh my goodness, this is all brand new stuff, this actually is review. Octet, when something has an octet, that means it has 8 valence electrons. So that means that it has the electron configuration of a noble gas. So the reason why ionic compounds and molecular compounds form is so that the elements that are involved can have the electron configuration of a noble gas, because that's what's stable, having this octet, 8 valence electrons. So what I'm going to do really quickly is explain the difference between an ionic compound and a molecular compound. And then for this lecture, I'm actually going to leave molecular compounds and we'll come back to them later in the unit. So the difference between an ionic compound and a molecular compound is that in an ionic compound, electrons are actually transferred. They are donated. They're given away. And so what will happen in an ionic compound is that one of the elements involved, which will be a metal, is going to give away an electron to a nonmetal, which will accept the electron. So as we've already learned, since the metal is giving away an electron, it will have a positive charge, while the nonmetal will have a negative charge because it's accepting an electron. Now, in a molecular compound, rather than donating and completely getting rid of an electron, what happens is that you have a sharing of electrons, and we'll get more into this later in the unit, but because you're sharing electrons and one element is not giving an electron away to a nonmetal, molecular compounds actually occur between two nonmetals. Okay? But for the purpose of this video, and for quite a bit of a couple more classes, we're just going to concern ourselves with ionic compounds, not with molecular compounds. All right? So what I'm about to go over should be nice review for you. So what happens, remember, in an ionic compound is that a metal gives an electron to a nonmetal, and what results is an attraction between the positive and the negatively charged nonmetal. So just as review, I'll give you the example of magnesium. Now, to know what charge magnesium will have, you know that magnesium has 2 valence electrons because it's in group 2, it's an alkaline earth metal. Now, magnesium wants the electron configuration of a noble gas when it becomes an ion. And so what it's going to do to become stable is it's going to lose these 2 valence electrons. It won't just lose one, it's going to lose these 2. Because it can either lose 2 or gain 6 to become a noble gas, to have the electron configuration of a noble gas. And so losing 2 is easier than gaining 6. And so if magnesium loses 2 valence electrons, it will now have the electron configuration of neon, which is a noble gas, which makes it stable. So that's why magnesium has a +2 charge. All right, so let's do one example, and then I'm going to have you complete the rest of this table right here. For sodium, sodium has 1 valence electron. So to assume the electron configuration of a noble gas, it can either lose 1 electron or it can gain 7 to have the electron configuration of a noble gas. So it would rather lose 1, so its charge would be +1. All right? So what I want you to do right now is for these other metals, determine what the charge of the ion would be. All right, so pause the video for a sec. Now we're going to go on to the negative ions. Okay, so remember, the metal becomes the positive charge because it's giving away an electron. The nonmetal is going to become negatively charged because it accepts an electron. So, in this example, chlorine has 7 valence electrons. All right, so you can count it, you can see it in the electron dot structure. So it can either lose 7 to assume the electron configuration of a noble gas, or it can gain 1. And so it's going to just gain 1 electron, giving it a -1 charge. So I'm going to do the one example on the next page. For nitrogen, nitrogen has 5 valence electrons. So what it can do, it can lose 5 electrons, or it can gain 3 valence electrons to assume the electron configuration of a noble gas. And so it would prefer to gain 3, so its charge is going to be -3. With that in mind, I want you to complete the rest of these examples. So pause the video for just 1 sec. Alright, now we're going to quickly go over the properties of ionic compounds, and then I'm going to show you how to write the formula for an ionic compound, which is really quite easy. Now, because ionic compounds are between a positively charged metal ion and a negatively charged nonmetal ion, the attraction is going to be extremely strong. So there's a strong attraction. And as a result of this strong attraction, ionic compounds are going to be solids at room temperature. One good, so solid at room temperature. One good example of an ionic compound that you work with every single day is just table salt, NaCl. Table salt is a solid at room temperature. The other important thing, because there is a strong attraction between the positively charged metal and the negatively charged nonmetal, ionic compounds have a high melting point. Meaning, in order to turn them into a liquid, temperatures have to be extremely high. Now, another fact about ionic compounds is important to remember when we start to write the chemical formulas for the ionic compound. No ionic compound has a charge. There is no charge in an ionic compound. No charge. Which creates a problem because, as you'll remember, magnesium, your metal, has a charge. It has a +2 charge, while chlorine has a negative charge, a -1 charge. And so what you need to do, you need to have enough chlorines to counteract the positive charge of the magnesium. So I'll show you the trick that I use for determining the chemical formula for magnesium chloride. I'll explain the reasoning behind my trick, and then I'll do one example problem with you, and then I'll allow you to do a couple on your own. So I call this the crossing charge method. So for magnesium, magnesium has a 2+ charge. All right? Remember, 2 valence electrons, it's going to lose those 2 electrons. Chlorine has a -1 charge. Now, I want the compounds that forms from magnesium and chlorine coming together to form an ionic compound to have no charge. And so one trick, the trick that I use, is cross your charges. So this -1 is going to become the subscript for magnesium. Okay, so that will be a 1. I don't include the negative charges, it's just the number that you put. So the 1 will go right here, and the 2 will become the subscript for Cl. I am crossing my charges. So what you end up with is Mg1Cl2. Now, remember in chemistry, if there's a 1, for example, in charge, or for your subscripts, it's implied, so you don't actually write it. So the formula, the chemical formula for magnesium chloride is just MgCl2. Now, the reasoning behind this is the following. If magnesium has a +2 charge and chlorine has a -1 charge, in order for this entire compound to have no charge, I would need 2 -1 charges, so a total of -2, so that the +2 and the -2 cancel. Now, I do that in my head. I don't actually cross my charges, but I think this is a really nice and easy trick if you have trouble doing that mental math. So, just as a review, since magnesium has a +2 charge and chlorine has a -1 charge, and your ionic compound can have no charge, what you end up doing, you cross your charges. Remember, you don't include the negative or the positive. The 1 goes as a subscript for Mg, which is implied, so I don't need to write it in the end. And the 2 becomes the subscript for Cl, so it becomes MgCl2, Mg with the +2 charge, Cl with a -1 charge. Since there are 2 of them, the net charge of MgCl2 is 0. All right? I'm going to do 2 more examples with you. I'm going to do magnesium, and I'm going to do the aluminum example. All right, for magnesium, magnesium has a +2 charge. Sulfur has a -2 charge. So when I go and cross my charges, the 2 will become the subscript for sulfur. The 2 will become the subscript for magnesium. And what you end up with is actually Mg2S2. Now, the formula, the chemical formula for your ionic compound has to be the simplest whole number ratio, meaning these 2's have to be reduced. Because both of these have a 2, you could reduce this to just Mg1S1. That's the only issue with crossing your charges. You've got to make sure that this is the simplest version. This is the simplest chemical formula. So I've got to get rid of those 2's, so I end up with Mgs. Now, reasoning-wise, Mg has a +2 charge, S has a -2 charge, therefore my ionic compound has no charge, and I've written my formula correctly. For aluminum and oxygen, aluminum has 3 valence electrons, so it has a +3 charge. Oxygen has a 2- charge because it has 6 valence electrons, so it's going to gain 2. The 3 becomes the subscript for oxygen. The 2 becomes the subscript for aluminum, and your formula becomes Al2. Remember, the minus doesn't come with it. Al2O3. To check myself, I say, okay, aluminum has a +3 charge. Since there are 2 of them, that is a total of +6. Oxygen has a -2 charge. There are 3 of them, so that's a total of -6. Therefore, this formula is correct because the net charge of my ionic compound is 0. All right? So what I would like you to do right now, just complete number 3 and number 4. And remember, if you struggled with this video, you need to go back and watch it again, whether it's reviewing of charges or how to cross your charges to create an ionic compound. And that's all I have for you.